Good morning, students. So I'm nice meeting you again for this online session. And this is the continuation of the lecture series on metrology and measurements. So we have started with the statistics, and the main concept of this lecture on a lecture series to introduce the metrology and measurements online, and anytime you can view this lecture series and make use of this lecture series for your exam preparation and for gate preparation and many things, right? We are continuing with the statistics, and last lecture series we end up with the mean deviation. Now we will start with what are the limitations of mean deviations. You can see here so the standard deviation. So now we are slowly moving on to the concept of standard deviation. Before moving into the standard deviation, we should identify or you have to understand what is the exact limitations of mean deviation. So mean deviation means here you have to find out the deviations from the mean value. So mean value, so we have to find how other readings we are taking from the particular measuring instrument, how these readings are deviated from the mean value. And mean value means what? How many readings you are taken, and you have to sum all the readings divided by, for example, if you are taking 10 readings, means divided by 10. If you are taking 100 readings, means you have to divide by 100. So then you will get the mean of a set of a group of readings, and we have to find out the deviation. To find out the deviation. So deviation in sense, we find the mean value, that is somewhat where the central tendency is existing. From the central tendency, how these other readings we have already observed from this instrument is getting deviated. So this deviation is very important, and only we can able to identify how the values are dispersed, okay, or varied from the actual reading, actual or true reading that instrument can be able to produce, okay. So in the mean deviation method, after identifying the deviation, okay, we have to find out the mean of that deviation. Previously, we identify the mean of the observations, that is readings. But here, after finding out the deviation from the central tendency, we have to find out the mean of that deviations, and we will find out, okay, this is the deviation, this is the value for average value from the deviation, right? So this is called mean deviation, but it has some limitations. So that is why we are going for the standard deviation. Okay, what are these limitations? Now we can read this. So in a series where the degree of variability is very high, so if the variability, that is deviations, are very high in a particular measuring observations, the median is not a representative of central tendency. We can calculate deviation based upon the median also, because median is also a measure of central tendency like mean. So if our deviations are very high or huge, then median is not the proper thing can you be used as or represent as at central tendency to measure the huge variation of deviations from the central tendency. So the mean deviation about median calculated is not fully relied. So that deviation, the total deviation or average deviation that we can calculate it from the median using this method cannot be completely trustable or relied, right? This is one drawback of this mean deviation method. Second one is the sum of deviations from the mean, that is sum of deviations from the mean is more than the sum of deviations from the median. So there are two central tendencies we are using, mean and the median. Sometimes we will find out the deviations from the mean, and we can find out the deviations from the median. And some of these deviations, deviations based upon the mean and some of deviations based upon the median are not always equal. Sometimes the deviation we are observing from the mean value may be more than the deviations we are observing from the median value. So there is no matching between these central tendencies. So those who are following median as a central tendency to calculate the mean deviation using the mean deviation method, so they maybe end up with the wrong reading or wrong interpretation. So this is one of the limitation of this method. So what they are saying, the mean deviation about the mean is not very scientific. This method is actually not scientific. Thus, in many cases, mean deviation may give unsatisfactory results also. That I already told you. There is a mismatch between the deviation calculated from the median and the deviations calculated from the mean. Because of this mismatch, you will get the unsatisfactory or unexpected, not reliable results we can end up with it. Therefore, we have to switch over to the another concept or method is called standard deviation. So variance. Before we are going to see about the concept of standard deviation, we should know about the variance and standard deviation. So what is this variance, concept of variance? Okay. So now we take these observations, x1, x2, x3, and xn. These are some of the observation of, if you are taking n observations. N observation means number of observations. The number of the observation, that is small n, will be 10 numbers, 50 numbers, 100 numbers, 1000 numbers, or 1 lakh numbers, 1 crore numbers, whatever may be. But these small n represent the number of observations, and x bar already this mean value or average value that we are calculating will usually represented as x over bar, right? So now we will find out the deviation. How we can find out deviation? So x minus x bar, x2 minus x bar, that is deviation from for each reading that is observed in the particular instrument, how it is deviated from the mean value. We will do in the previous example of mean deviation, we did the same thing. Additionally we are squaring that value. Okay, they are squaring that value. So previously in the mean deviation, if you do, for example, if you get the minus value of this x1 minus x bar, okay, for x1 minus x bar, and this is, for example, this is x1 is 10 and x bar is 3, and you will, sorry, x1 is 3 and the x bar is 10, then you will get the value. This value will be -7. Okay, but we have to take or consider the absolute value. For absolute value, we have to take the modulus of it and convert that minus value into positive value. But here they are squaring up. Okay, they are squaring up this activity, and they are converting into a positive value. Okay, so without making as a modulus, we are converting into a positive value by squaring it, x1 minus x bar. So if you -7 is I will getting means, if you square it 49 something, it will come. Okay, so previously if you're not squaring up, this total sum will be equal to 0. Okay, total sum will be 0. So for example, I will take this example. So take this example of 5, 15, 25, 35, 45 and 55. This is one set of observation, and if you find out the mean of this observation, you will get mean of these 5, 15, 25, 35 and 55. You will get 30, right? There are 6 observation. So then we have to find out the deviation from this for observation. So how we, in this new method, now we are dealing with the variance. We are dealing with the variance. So for now we slowly going entering into the concept of variance. So step by step, I'm explaining you about this concept. So this formula, you have to squaring up. So 5 minus 30 whole square plus 15 minus 30 whole square, like this. Then we will get the total deviation. Total deviation is 1750. 1750. And you take another set of observation, that is B. For example, some systems, and you will getting the 31 observations from 15 to 45, 31 observations. And here also, if you find out the mean value will be the 30. Okay, y bar means mean, and the x bar means mean of the x values, and y bar means mean of the y values. And they are both are same. Already we have seen in the last lecture that the batsman example, the mean of the both batsmen A and B are same. Then how we can compare those batsmen, like, and how to, we can select the capability, identify the capability of the batsman. So here also we are getting the same mean, but number of observations are different, and but the scattering is also different, right? Now here they are finding out the deviation, and they found out 2480 is the variance. This is called the variance. Okay, now you can see so this difference. Now you can see this value here, how these points are scattering for set of observation for A and the set of observation for B. So how we can able to differentiate it, which is more scattered and which is completely concentrated within this near to the mean value. So that is the problem here that we have to identify. Now that you can see the deviation is starting from -25 to 25, and here this mean that range of deviation is from -15 to 15. Okay, because here you can see from 30 to 30 minus 5 minus 25, 5 minus 30 minus 25, and 55 minus 30 plus 25. So these are the range of deviation for A, and here you can see the range of deviation 15 minus 30 minus 15 minus 15, and 45 minus 30, you can get the 55. So this is the range of deviation. Among the range of deviation, we have to find out some meaningful interpretation. To find out the meaningful interpretation, we have to take the average. Okay, take the average. So this is the now what we have done in this method. We are converting into positive values, right? We are converting the deviations into positive values by squaring, making a square over them, and we are summating everything. Okay, for each deviation is getting converted into positive values by squaring them. Okay, instead of making modulus, we are converting into a square. We are converting them as by squaring them, right? And to find out the meaningful interpretation from this observation, we are taking the mean of it, mean of these deviations. Okay, now this, you see this formula here. So 1 by n summation of I to n x of I minus x bar whole square. Okay, now for A, in case of observation A, it has 6 observations, and this sum of xi minus sum of the deviations. Sum of the deviation is 1750. How this 1750 we arrived here? Okay, we arrived like this. So this 1750 square of sum of the deviations. Okay. Previously in the mean deviation, we never did this square value. We just convert or take the absolute value of this deviation, and we add all the deviations, and we divided by the number of observations, and we identified or come up with the mean deviation value. But here in the concept of standard deviation, now we will find out we will define the concept of variance. So here we are not taking the modulus. We are not converting into the absolute value, actual value into absolute value. Here we are converting the negative values into positive values by squaring of them, right? This deviation minus 5, that is 5 minus 30 minus 25, this 25 squared, then you will get these 625 like this. So then if you summing up all the deviation, square of all deviation, you will get 1750 for the observation, a set of observation. Okay, and here to find out the meaningful interpretation, we are dividing by the, or you are taking the mean of these observations. Okay, 1 by 6. Now 1 by n, this is the formula, right? Here n is for A, in case of A observation, 6 is number of observation. Now you get 291.67. So this is the mean of deviation, mean of square of deviation. Remember, this value 291.67 is mean of square of deviations. And for B, this, if you apply in this formula, you have to divide this value by 31. That is, number of observation is 31. You will get 80, right? Now you can see this 80 is the mean of square of deviation. Now it gives a more meaningful value, right? A shows, then A observation shows more scattered when compared to the B. The B is somewhat the scattering ability, the scattering nature is very much less when compared to the observation A. So now you will get some meaningful information by taking this or incorporating this formula. Okay, so this is called this formula 1 by n summation of the square of deviation. X minus x bar is deviation, and we are doing the square. So this is the square of deviation. This 1 by n, this mean of the square of deviation is called variance, right? So this mean, always I am again repeating, the mean of square of this deviation is called variance. So we represented the square of variance as sigma square. Okay, sigma square. So this is variance value is sigma square equal to 1 by n summation of I1 to n x minus x bar whole square. Then we will find out the standard deviation. So how this scattering, the nature of scattering, the standard deviation explains the nature of scattering and how it is deviated from the true value. Okay. So in this calculation of variance, we find the units of individual observation and units of the mean and different from the variance, right? And we are summation and making the square of this variance. The proper measure of dispersion. So now why we are doing, we have to find out how these data points we are observing from particular instrument is dispersed, and we have to find out the deviation from the mean value, and that should be scientifically acceptable. That is why we are following these methods to make these observed deviations that can be scientifically acceptable. So now if you taking the square root, this is if you may keep it as such means sigma square 1 by n, this formula, this is called variance. We have to find out the variance. This is the first step, like, to find out the standard deviation. Now if you take the square root, if it is a negative value or positive value, whatever may be, if you take the square root, then you will get the standard deviation, right? Standard deviation. So this is the formula for standard deviation. So no need to mug up. No need to mug up of this formula. You already know to find out the mean deviation. We already know to find out the mean deviation. That is, all the steps are clearly explained. If you remember these steps, you need not to mug up this formula for standard deviation, right? The first step of identifying the standard deviation is to find out the variance, right? To find out the variance, we have to find out the deviation value, deviation x minus x bar, deviation value. After identifying the deviation value, you have to square all the deviation value, and you have to add all the deviations, squared value of all the deviations. Then you have to take the mean of that. Mean means what? Average. Already I explained you. This is the basics of it. Okay. If you want, you can go through my last lectures and find out how to take the mean. In this lecture also I explained you clearly. Then this is called variance. If you take the square root, this is square root means this sigma square value will be vanished, and you will get the standard deviation. So for example, in the example, take 6, 8, 10, 12, 14, 16, 18, 20, 22, and 24. There are how many numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 observations are there. These are 10 observations from any particular instrument. And you have to find out the mean. So mean as 14, that from the central value, that assuming as a 14. Otherwise you can calculate the mean value. Okay, how to calculate the mean value? You have to add all the things: 6 plus 8 plus 10 plus 12 plus 14 plus 16 plus 18 plus 20 plus 22 plus 24 divided by 10. Then you will get the mean value. Then what's the next step? Next step is, so xi means each individual observation. Okay, xi1 means, x1 means 6, x2 means 8, x3 means 10, x4 means 12, like this. Okay, x10 means 24. So this is the xi, and you have to find out the deviation. Already we found out the mean value, so we have to subtract the deviation. Okay, xi minus 14 and divided by 2, deviation. Okay, how much it is deviated from the mean value. Okay, how it's deviated mean value, you have to find out. Okay, that is this is important. So this is important. Instead of this step, this is very important. Deviation from the mean is very important. Xi minus x bar. So x bar means what? And this is 14. So 6 minus 14, like this you have to find out, right? And you have to square the this square of this mean value. You have to take it. and 7 49, 5 is 25, 3 9, like this you have to do it, and you have to add all the squared deviation value, 330, right? And you have to find out mean variance. You have to find out the variance. Okay, so the variance is 1 by, already I told you, this value 330 is, this 330 is summation of 5 to 1 to 10 xi minus x bar whole square. This is the value of 330, and if you divide by 10, you will get the variance of 33. Then if you take the square root of this value, the square root of 33 is 5.74. So 5.74 is the standard deviation from the mean value of these 10 observations. For clear understanding, I will explain with another example. Take this example of the height of different dog breeds. There are different dog breeds. Okay, these are foreign dog breeds. So you have to find out how these dog breeds heights are deviated from the normal dog height. First of all, we have to find out what is the normal dog height, and from the normal dog height, how these dog breeds are, heights of the dog breeds are varying. Okay, that is deviation. Okay, from the normal dog height, how each and every dog is getting deviated, and we have to find out. For example, for this dog, this is Rottweiler dog. I know this name of this breed. So this black dog, black color dog, is 600 mm height, and second, this is 470 mm height, and this is very short, 170 mm height, and this is medium, 430, and another dog is, last dog is 300 mm. So these are different dog breeds heights. Okay, and we have to, first step is to find out the mean. So okay, how to find out the mean? How to add all the heights, 600 plus 470 plus 170 plus 430 plus 300, and divided by how many dogs? 1, 2, 3, 4, 5 dogs, divided by 5. Then you will find out the 394. 394 is the mean height of these dog breeds. Okay, but this is not giving any meaningful information. This is the mean height. Okay, what is the use of this mean height? Identify the mean height. It's the normal height of any dog, and from that, how these each and every breed getting varied, height is getting varied. So now this, you can see a green color line. This green color line is this value 394 mm, that is mean value. From that, you have to find out the deviation, how this each and every dog is getting varied, height of this dog is getting varied. Now you can see this black dog is 206. Now we are finding out the deviation. Okay, 206 is the deviation from the normal height, that is mean value. So 600 minus 394, 206, and like this 470 minus 394, and we have to do the square also. Okay, this is first we are finding out the deviation, not we are making the square. Next step only we have to take the square. So 76, you will get the minus value. The minus value means you convert it into positive value, but here naturally it is positive. And if you take this short dog, 170 minus 394, you will get minus 224. It is below the normal value. And this 430 minus 394, 36, and 300 minus 394, you will get the minus 24. So here we identified the deviation from the height of each and every dog breed. Then we have to find out the variance. So we have to square it up, sum it up and square it up. 206 square, 76 square, and minus 224 square, 36, all the deviations are squared, and you find out the square values and divided by what is variance? Summation of square of all the deviations by number of observation. Here number of observation means there are 5 dogs are here, these are the number of observation, so 5. Now you can see this value, you can get the, this is the variance 21704. This value, this numerical is the variance of it. And what is the use of this finding out the variance? What it tells? So without doing the finding out the standard deviation, you never understand the meaning of this value 21704. If you stop with this 21704, there is no meaning of it. You cannot able to understand what is the meaning of this 21704. For that, you have to take the square root of this variance. Okay, how it is varying. If you take square root, you will get 147. 147. So, what is the meaning of it? Standard deviation, you can see this example, another example, the same example. This green color is the standard, that is mean value, that is normal value, that is 394. Exactly correct? Yes, 394. So from this normal value, how this height of these dogs are varying standardly in that standard form, in standardly how these dogs are getting, height of these dogs are getting varied or deviated from the normal. Okay, so for in uppercase maximum it goes to 147 mm. In very worst case also, normally it will these dog breeds, the lower dog height of will be deviated from 147 mm. There is past in upper 147 and lower 147. So we have to add 394 plus 147. What will be the value? This is the upper value. Normally all the dogs will be in the height. Some exceptional heights will be there of this black dog. Okay, that is not a problem. But normally these dogs will be, these foreign dogs, breeds of dogs will be deviated. Height deviation will be, so 394 plus 147. Maximum height will be this one. Minimum height, shortness of the particular the dogs will be 394 minus 147. Okay, now you can see here. This is the shortest dog and the tallest dog. This is the meaning of this observation, right? So now we can end up with this standard deviation. I hope you understand the concept of the standard deviation. So in next lecture, we will discuss about these errors, right? Measurement errors, right? Thank you.